Welcome to myprojectbazaar.com. The title of the project is Systematic Poisoning Attacks on and Defenses from Machine Learning in Health. The abstract of the project is machine learning is being used in a wide range of applications domains to discover patterns in large datasets. Increasingly, the result of machine learning drive critical decisions in applications related to healthcare and biomedicine. Such health-related applications are often sensitive, and thus any security breach would be catastrophic. Naturally, the integrity of the results computed by machine learning is of great importance. Recent research has shown that some machine learning algorithms can be compromised by augmenting their training datasets with malicious data, leading to a new class of attacks called poisoning attacks. Hindrance of diagnosis may have life-threatening consequences and could cause distrust. And the flow diagram of the project is: first we need to start our program and select the KDD-GUP99 dataset. Then we use the sample dataset in our console working directory. Then it will process it into data pre-processing. In data pre-processing, we are using data cleaning method and label encoding method. In data cleaning, we are going to check the missing values and null values in our dataset. If it is contains any missing and null values in our dataset, we need to replace or drop the columns. Then it will move into label encoding. In label encoding, we are going to convert the string data into numerical data. So after that, it will apply it into model selection. In model selection, we are going to select the independent variable and dependent variable. After selecting independent and dependent variable, we are going to split our dataset into training dataset and testing dataset. Then it will move into classification. In classification, we are using 3 different types of algorithm, 2 different machine learning algorithm and 1 deep learning algorithm. Namely, the machine learning algorithms, namely naive-Bayes algorithm and support vector machine algorithm, and deep learning algorithm, namely recurrent neural network algorithm. And 3 algorithms are used to train our dataset and generate the result in the form of matrices like accuracy, precision, recall, F1 score. The program was successfully executed in Anaconda Navigator Spider IDE, and this is our first module, input module. In that I have to read our KDD dataset and view the sample dataset in our console working directory. After that, it will implement it into data pre-processing. In data pre-processing, I am going to check the null values, but in our dataset there is no null values contained in our dataset. So after that, I have to apply the label encoding method for selected columns. The label encoding method, which is used to convert the string values into numerical values. So this is the label encoding results for our dataset. So in that, I have to apply the label encoding for protocol type. So after that, we are going to select our independent variable and dependent variable. After selecting independent and dependent variable, I am going to split our dataset into train dataset and test dataset. So this is our independent attribute result, and this is our dependent or target result attributes. So this is the count plot between the number of normal classes and number of attack classes obtained from our dataset. So after that, I have to implement the algorithm. In that, I have to use 2 different machine learning algorithm and 1 deep learning algorithm, namely naive-Bayes algorithm, support vector machine algorithm, and the deep learning algorithm name is recurrent neural network algorithm. First, I have to apply the naive-Bayes algorithm. The naive-Bayes algorithm, which is provide the accuracy result, is 53% to train our dataset. And these are the classification report for our naive-Bayes algorithm for normal class and attack classes. In classification report, we are going to generate the precision value, recall value, F1 score value for normal and attack classes. The precision means number of correct prediction, recall means number of correct instance of prediction, and F1 score means to measure the test accuracy. And after that, I have to find the confusion matrix for naive-Bayes algorithm. This is the confusion matrix result for naive-Bayes algorithm. The confusion matrix result, which is explains the number of correct prediction and number of misclassifications obtained from our naive-Bayes algorithm. So our second algorithm is support vector machine algorithm. The support vector machine algorithm, which is provide the accuracy result, is 53%, and these are the classification report for our support vector machine algorithm, and this is the confusion matrix for our support vector machine algorithm. So final algorithm is recurrent neural network algorithm. The recurrent neural network algorithm summary result is These are the summary result of recurrent neural network algorithm, and which it will extract the trainable parameter from the recurrent layer. So based on the trainable parameter, we are going to train our dataset by using the new recurrent neural network algorithm for 10 different training epochs, and it will provide the accuracy result is 87%. And these are the classification report for recurrent neural network algorithm, and this is the confusion matrix for recurrent neural network algorithm. And finally, we are going to compare the difference between the performance difference between the naive-Bayes algorithm, supported transmission algorithm, and recurrent neural network algorithm. The recurrent neural network algorithm, which is provide the higher results than the other two algorithms, and these are all the variable results that we are get from our process.